We are looking at circles, and we're looking at chords, tangents, and secants to circles. So we're specifically looking at finding angles today. Your essential question is, how do I find missing angle measures with chords, secants, and tangents? Your learning intention. I'm learning to find missing angle measures in circles with chords, secants, and tangents. For your warm-up, find the indicated variable and the missing angle measures. So if we have a variable, that's great. If not, that's fine too. If we're looking at this, the first two are warm-up questions. Please pause the video and see if you can do those on your own. Well, I do hope you tried. If I'm looking at angle V, I notice I have a triangle in my circle. So these match up. That's your intercepted arc and your angle. This is an inscribed angle, so I know it is half of the measure of its intercepted arc. So I'll take 98 degrees, divide it by 2, and I get 49 degrees. So this angle is 49 degrees. Likewise, if I'm looking at this intercepted arc, it goes with this circle here. Once again, it is 1/2 of the measure. So I take 112 degrees, divide it by 2, and I get 56 degrees. How many angles are in a triangle? 180. We know 2 of them, and we can find the third one easily. 180 degrees minus 49 degrees plus 56 degrees equals Okay, so I've got in the calculator, I end up with 75 degrees. So this is 75 degrees. Is that the only way I could have done it? No. I might have been, I also could have found the rest of the circle. I could have taken 360 degrees minus 112 degrees plus 98 degrees. And I would have gotten 150. This would have been 150 degrees, and then when I divided it in half, this would be 75 degrees. Both ways work. You're going to do it the way you see. So if I'm looking at the next one, I notice this is my angle. This is my intercepted arc. To go from the angle to the intercepted arc, what do we do? If you said multiply by 2, you would be correct. So 55 times 2, that's 55 degrees times 2, is 110 degrees. Okay, if I'm looking at this, I notice this angle here also intercepts that arc, so this one has to be 55 degrees also. Can I find any others? I claim that you can find this piece right here. What is that piece right there going to be? It'll be 180. This is a semicircle, goes through the center. So 180 degrees minus 110 degrees will give me 70 degrees. If I notice, this will come down to this angle here, and this will be 35 degrees. Are there any others we can do? Well, we know the whole thing over here is 180. I've got part of a triangle going there, but I don't really have enough to know what else to do, actually. So if you're looking at that, we've gone as far as we can. Those are all the angles we can find at this point. If we go into the intersecting chords angle measure theorem. If two secants or chords intersect inside in the interior of the circle, then the measure of each angle formed is 1/2 the sum of the measures of its intercepted arcs. If you're looking at the example, here's AC, here's DB. And we would add those two arc lengths together and divide by 2. And that would give us the measure of those interior angles. Both of them will be the same because they're vertical. So let's apply. If I'm looking, I've got this and this are my two intercepted arcs. So I can say 155 degrees plus 79 degrees, and I'm going to multiply it by 1/2 or divide by 2. So to do it all at once in my calculator, I'm going to use the decimal point 5 times parentheses 155 plus 79, close it off, and I get 117 degrees. That is my 117 degree angle. What would this angle here be? Oops, that's the wrong angle. I did it on the example, didn't I? Let me get rid of that. This one here is 117 degrees. I can find another angle. Do you know which angle I can find? Well, I can actually find this angle here. If this one's 117, this one's 117, they are vertical angles. 180 degrees, I've got that straight line, minus 117 degrees is equal to 70, 60, 53 degrees. Now, always check your math if you're doing it in your head. And it should have been 63 degrees. It's a good thing I checked. So these two will be 63 degrees. So you found all the inside angles. Do we know what these two arcs are? No. We'd have to know one or the other, or know that we had a semicircle. We cannot find these arcs because we're adding them together and dividing by 2. Okay, how would you set the next one up? Well, think about how you would use that formula. the measure of that angle. So the angle is 126 degrees. It is equal to 1/2 of, I know this one's 50 degrees, plus x degrees. How do I solve? Well, I start off, I'm going to get rid of my fraction, so I'm going to multiply both sides by 2. $126 times 2 gives me 252. And that is equal to 50 degrees plus x degrees. So I'm going to subtract 50 from both sides. And 202 degrees is equal to x degrees. So this is 202 degrees. Okay, if you've got a secant and a tangent that are in the exterior, if you're looking inside, we add. What if you're looking outside? What is the opposite of adding? Subtracting. So if a tangent and a secant, two tangents or two secants, intersect in the exterior of the circle, then the measure of the angle formed is 1/2 the difference of the measures of those intercepted arcs. This time, if it's inside, we add and divide by 2. If it's outside, we subtract and divide by 2. If it is on, we simply divide by 2. Inside, outside, and on are the 3 ways you can have intersections. So these are kind of showing you all the different ways you can have those intersections. It's outside, so I'm taking AD minus BD and dividing by 2. Two tangents. I'm going to take BAD minus BD and multiply by 1/2 or divide by 2. Once again, AE minus BD, and then we will divide by 2. So let's look at what we've got going on. Now the first one, we know the angle measure and we're looking for that outside arc. So let's use the formula. We've got 44 degrees is equal to 1/2 of x minus 65 degrees. Now we're going to solve for x. Multiply by 2 on both sides. 44 is equal to, or 88 is equal to. 44 times 2 is 88. 88 is equal to x minus 65 degrees. 88 degrees. Add 65 to both sides. $153 degrees is equal to x degrees. So this would be 153 degrees. Okay, take a minute and look. Do you have any questions? Do you see how it works? You're applying one of these three formulas that are up above. Now the last one is kind of thought-provoking. I'm looking for the angle measure, but it only gives me one of the arcs. I still need to know this outside arc. How am I going to find it? Well, I know the whole circle is how many degrees? 360 degrees. This part is 110 minus 110 degrees is equal to 250 degrees. So this will be 250 degrees. Any questions? Now we're ready to solve. X degrees is equal to 1/2 of 250 degrees minus 110 degrees. X degrees is equal to 1/2 of 250 minus 110 will give me 140 degrees. X is equal to 70 degrees. So this angle here will be a 70-degree angle. Look at the formula. Find the missing pieces. Substitute the missing pieces that you know in to find the other. How do you know when you're successful? When you can find the missing angles of circles with chords, secants, or tangents. So, if intersect inside, add arcs, so add the arcs, divide by 2. If it intersects on if the vertex is on the circle, you simply divide it by 2. If it intersects outside, you subtract your arcs and you still divide by 2. So inside, outside, and on. Inside, add, divide by 2. On, divide by 2. Outside, subtract, divide by 2. Just remember inside, outside, and on.